Physics and measurements. The laws of physics are expressed as mathematical relationships among physical quantities that we will introduce and discuss throughout this entire video lessons. Most of these quantities are derived quantities, in that they can be expressed as combination of a small number of basic quantities. In mechanics, the three basic quantities are length, mass, and time. All other quantities in mechanics can be expressed in terms of these three. First, let us discuss length. In AD 1120, the King of England decreed that the standard of length in his country would be named the yard and would be precisely equal to the distance from the tip of his nose to the end of his outstretched arm. Similarly, the original standard for the foot adopted by the French was the length of the royal foot of King Louis XIV. This standard prevailed until 1799, when the legal standard of length in France became the meter, defined as 1/10 million, the distance from the equator to the North Pole along one particular longitudinal line that passes through Paris. Next, mass. The SI unit of mass, the kilogram, or kg, is defined as the mass of a specific platinum iridium alloy cylinder kept at the International Bureau of Weights and Measures at Sèvres, France. This mass standard was established in 1887 and has not been changed since that time because platinum iridium is an unusually stable alloy. Lastly, we have the time. Before 1960, the standard of time was defined in terms of the mean solar day for the year 1900s. A solar day is the time interval between successive appearances of the sun at the highest point it reaches in the sky each day. The second was defined as a mean solar day. The rotation of the Earth is now known to vary slightly with time. However, and therefore, this motion is not a good one to use for defining a time standard. In 1967, the second was redefined to take advantage of the high precision attainable in a device known as an atomic clock, which uses the characteristic frequency of the cesium isotope 133 atom as the reference clock. The second is now defined as 9,192,631,770 times the period of vibration of radiation from the cesium atom.